we're looking at series. Can you remember a series is basically what you get when you add a sequence up? Oh, I've got a chat already. Oh, that's all that is. Okay, so what you're looking at here is essentially what we're kind of going to try and cover today, and is an awful lot, so I don't want to hang around. How do you find the sum of a series? How do you find out what a series adds up to, essentially? And sometimes all you're wanting to really know is that it converges. And sometimes, if you're really lucky, you will want to be able to find what it converges to. That actually isn't that easy to do in many equations. It is possible to tell if it converges or not, but not always that easy to find out what it adds up to. And so you're going to find a lot of situations, especially in the next week or so, where we'll be able to prove that a series converges, but we won't be able to tell you exactly what its value is. We can tell you approximately what it is, but not what it is exactly. So, first kind of question, so I've kind of called them method 25, is that you're given a formula for the partial sums. So imagine that you've got your sequence A1, A2, A3, A4 for infinity, and your series then is what you get when you add it up. And we normally write that down using sigma notation. I'm going to use K because I want to. I'll use N, okay. There. That would be the convenient way of doing it. And what we tend to do now is that if we want to find out, does this actually add up to a number, in which case we say it converges to that number, or does it go off to infinity, in which case we say it diverges? Well, if you tell me, or what we do then is that we find its partial sums. S1 is what you get when you only add up the first term. S2 is what you get when you add up the first two. And S3 is what you get when you add up the first three. So one of the techniques that we use is that we find these guys and all the others that come after it. And if the sequence of partial sums, that's what these guys are called, Sn in general, converges, then the series converges. And what does it converge to? Well, if it converges, the series S will be whatever the limit as n tends to infinity of its partial sums are. So it's almost like a circle. You have a sequence, you add all the terms and that becomes a series. From that series, you create a different sequence made up of its partial sums, right? S1, S2, S3, S4. And you analyze what that sequence does. And if that sequence converges, then you can assume that the entire series, right, what you get when you add them up, converges, and it converges to whatever the limit of the sequence happens to be, the partial sum one. So that's the theory behind quite a lot of these techniques. So suppose we'll do method one. Suppose I give you a formula. Wherever it came from, we don't know, but somebody was lucky enough to find it for us. And so we're going to use it. Suppose I tell you that the partial sums happen to be 1 take away 0.3 to the power of n, right? And we're being asked, quite simply, does this series converge? And if it does, tell us what it converges to. And if it doesn't converge, then you just type in the word diverges. So I will find the limit of the partial sums as n tends to infinity. So I'm going to be finding, oops, the limit as n tends to infinity of this guy. Okay. We've done limits of sequences before, for limits of expressions. Do you recognize this guy as one of those we just know the answer? Isn't this a number less than 1? What happens to the limit of a number that's less than 1 if you raise it to the power of n? What does this limit be?
0.
It's 0. So won't this become 1 take away 0? Won't this become 1? So what we can say is that for question, actually this is, what is this? This is very like question 2 in your homework, for instance. We would say that this guy converges to 1. And what you would do in the homework is you just put a little 1 there. That's all they want. But there is working, right, involved in coming to that. Suppose I gave you a partial sum formula and it looked like this guy. Right, good harm. If you find the limit of this partial sum formula, would you agree this is just another one of those that brute force does the work? Would 2 to the power of infinity be infinite? And wouldn't 1 plus infinity be infinite? And when a limit is infinite, we just say that the series diverges, right? And in the box in your homework, you just type in, I think it's capital letters. That's all you will write down. So what you write down in your homework questions is either the number that it converges to, if it converges. And if it doesn't converge, right, it goes infinite or it goes weird and there's no answer, right, it jumps everywhere, then you would just say diverges. You don't even put infinity in, just diverges. Do we feel good about that as our first method? If you give me partial sums. Okay, let me zoom over to where.
I have a question about
Yes.
for the test. So when we're writing the answers, would you like us to write the sentence out, this converges to this number?
I don't mind. It's nice
Sounds
if you
good.
if you do it, I will like it, but I won't ding you if you don't. As long as it, essentially, this is what I would expect to see if that was a homework, if that was a test question. And I'm not sure what you can see right now because I've forgotten where I am. Can you still see what I'm pointing at with my finger? Or
You're in space.
Yeah.
What does that look like? You see my ugly face like close up?
No, you're in space.
Oh yeah, I am. Yeah, me and my wife had a problem, so I'm kicked out right now. No, we don't. I'm too nice a person for anybody to fall out with, right? Yeah, you believe that, you believe anything. Okay, so God, I shouldn't talk, and I can't multitask to save my life. Here we go. There we go. Now, that's how they phrased the first, my example there. Do you see? They generally have this sentence up here, and then they give you the partial sum formula. So would you agree that this one converges? You should be able to just look at this one. What number does this converge to in question 2?
8.
Agreed. Now, question 3. There is the partial sum formula. You see it? What does that converge to? Because it does converge.
Third.
Okay. In homework, you're just going to put a third down, right? But in a test, you're going to prove it to me. There are 2 ways to prove that. What techniques would you use to prove to me that's a third?
Divide by n squared on the top and bottom, or use L'Hopital's rule.
Agreed. So we're working in two worlds here. We're working in the homework world where all WebAssign expects is the answer because it's not very clever. And then we're working in the math world where numbers and answers don't matter. It's proving them matters if you can. Occasionally, we do have exceptions to the rule. For instance, wouldn't this one basically just be 8 take away 0 equals 8? That's about all the working I would see from that one. Now, I guess do you want to go here? Do you want to go there? I'll go here. Right, here we go. Let's show you now a second technique. So if somebody gives you a partial sum formula, you know, just find the limit of that partial sum. If it's a number, it converges. If it's not. The second method is you find the first 5, 6, 7, 10, 8 partial sums and you make a conjecture. So you get, for instance, a series that looks like this. And I'm going to pick a much easier one to do. And it's going to be 1 over n squared. And all we're going to do is calculate the partial sums. And write down what the answers are. And there's a lovely little video that shows you that you can let your TI-84 do this for you. And the first one is what 1 squared is 1. The second is 1 plus a quarter. So I'm going to call that 1.25. The next one is going to be 1 plus, let's do it, 1.25 plus a ninth. So that's this answer. And now if I want S4, can't I just use that answer and add a 16? Isn't that already 1 over 2 squared, 1 over 3 squared? So you just say plus, and you do 1/16, and I get the answer 1.4236. And then I add 1/25, which is the next term, 1.4636. And then I add 1/36, and I get 1.4913. And then I add 1/49, and I get 1.51179. And then I do add 1/64, and I get 1.527422. Now, if you are lucky, which I'm not, you should be able to make a conjecture. Conjecture is just a fancy word to sound better than it is. A conjecture is an intelligent guess. I can't prove that I'm right. I'm just doing my gut feeling. Am I right or am I wrong? And so you look at these guys and you've got two answers. Yes, I think this set of partial sums is beginning to level off a number, or no, it's not, it's shooting off to infinity. Now, it could be that your conjecture and my conjecture will be different because your guess might be not the same as my guess, right? But there's only two choices. So is your gut feeling that this sequence of partial sums is converging to a number eventually, or does it look like it's getting bigger and bigger forever?
It's getting bigger and bigger forever.
Because it's going a little bit more, but a little bit more, right? Does anybody want to come down on my side that it converges?
I think it goes to pi over 2.
Not only does it go to pi upon 2, someone knows that that's one of the standard series. So the answer is yes, it converges. Now, does that make the first person wrong? No, because I can see why they're getting there. If you looked at the difference between one number and the next, and this isn't a guarantee, isn't this going to be 1 over 81? Isn't it going to increase by less and less and less? So that's not a guaranteed proof, but it does converge. I suspect, and I hope, that when you get a diverger, it will be so obviously diverging that you won't think about it. So I'm making up a series. Can you imagine I had a set of partial sums where it was 1, 3, 20, 411, 5,000, and so on. Would you agree that that one is clearly diverging? We don't need to worry about it, right? What about a sequence of decimals? I can honestly tell you that at least half the time I end up guessing wrong, because it's quite hard when the numbers aren't increasing by a lot, because it could be that, you know, that's enough to make it get infinite eventually, right? No, if I add 0.1 to a number, and then I add 0.1, and then I add 0.1, wouldn't that number eventually become infinite? Even although I'm only adding a tiny bit. So when it diverges, it will be kind of obvious that it diverges, right? The numbers are just getting bigger every time. If it converges, it will probably look more like this one, where the answers are increasing, because they will, typically, but they'll be increasing by less and less and less. So they're kind of leveling off eventually. We okay with that? Now, if
Are
you,
we supposed to figure out what it converges to? Like the partial sums,
fine.
like you get like the decimals?
No, is the short answer, which is good, right? It's easy to do divergent because it's infinite. I know that that converges, and someone else who knows what the answer happens to be because it's a standard one. But looking at that, I couldn't. If you put me in the spot, I would say it converges to a number around about 1.5-ish, 1.6-ish. But I mean, that's as good as I could guess. So no, they're not going to ask you. In fact, what they do ask you, let me show you, is just one word. So here's the one you're going to do it to. You're going to add the answers in here. And then you're just going to say converge or diverge. And because you get 5 guesses, you know if you guess wrong, won't you be able to guess right the second time? But hopefully the first time at least, you give it a bit of thought before you commit, right? Yeah, my gut feeling is it's not going to make it, diverges. Or my gut feeling is, yeah, it's probably going to eventually, you know, level off at something, and in which case it converges. I can tell you right now that that one is going to diverge. And you might say, well, how can I know that? And I haven't even written down the partial sums. Won't the sine of 1, the sine of 2, the sine of 22, you know, all the terms you're going to add together, aren't they pretty random? Don't they jump all over the place? Now, can you imagine adding up an infinite number of relatively random numbers between 1 and -1? That the answer is going to jump all over the place, right? And so I'm very confident that one ends up being divergent. This one, I'm pretty sure that one's going to diverge, but I'll let you figure it out. And now I'm going to return back to our notes. So if you are given a question where you find, say, the first 8 partial sums, you look at a pattern from top to bottom, and you make up your mind, you decide, you make a conjecture on whether or not you think it's got a pattern that's leveling off, in which case you say it converges, or whether there's something, you know, weird about it and it diverges. Let's look at method 3, called the divergence test. I believe that there are 9 tests in dealing with a series, 9 algebraic tests. It's a lot. That's why this takes 2 weeks, 2 weeks to do. And the divergence test says this. For the series, n equals 1 to infinity an, right? For that series, if the limit as n tends to infinity of just one term, right? The general term, if that is equal to L, where L is not equal to 0, then the series will diverge. So if you have a series made up of terms and the terms themselves have a limit that's not 0, then the series will diverge. Show you what that looks like. Suppose I, is that, yeah. N equals 1 to infinity. Suppose I do this series. And all I'm being asked to do is tell whether it's convergent or divergent. Then the individual sequence that it came from, that's its formula. Right? That's basically the an, isn't it? And I now find the limit as n tends to infinity. Okay, what's the answer to this limit? What's the limit of each individual piece? What's the limit of this?
3/4.
Okay, and you could prove that to me, couldn't you, by L'Hopital or divide total bottom by n? I'm just skipping that bit for time. Now, according to the divergence theorem, isn't this limit not 0? Isn't this 3/4? It's clearly not 0. So what's my conclusion? This series diverges. It's called the divergence test. Pretty simple test, right? If the individual bits have a limit that's a number, it diverges. The opposite of that, unfortunately, is not true. If the limit of the individual terms is 0, it doesn't mean that it converges. If that was true, we would do series in a day. We would just say, find the limit of the thing. If it's a number, it diverges. If it's 0, it converges, right? Wouldn't that be really easy? That'd be great. We could do some other stuff for the next 2 weeks. But all the divergence test does is it tells you that it diverges. So you might say, well, what happens if I get a question where the limit is 0? So suppose someone said that one. Well, the limit as n tends to infinity of this guy is 0. The divergence test tells me nothing. All that means is it's inconclusive. The divergence test doesn't guarantee that that series, this one here, converges. In fact, I happen to know that one, isn't it? It's the harmonic one that diverges. Yet something that looks very similar to it, which is that one, has the same property that its limit is 0, but this one actually, later on, we'll prove it to you, using one of the 9 tests, actually does converge. So you see, you can't really tell when the limit is 0, whether it converges or whether it diverges. And because we cannot tell, we say inconclusive, right? We don't know yet, essentially. Are we good? It's called the divergence test. And let's see some questions where that gets used. Okay, question 7. 8n over 3n plus 1. So basically, they're breaking this question into 2 bits. What the limit of the sequence is and then what the series would be. would you agree that the limit of this guy is 8/3? And 8/3 converges, right? It converges to 8/3. But what about the series it's made up from it? Ah, diversion. Now, if you're a lazy person, you're just going to guess, get it wrong. Guess, get it right. But when I hit you a question like that in the test, telling me convergent, divergent, don't care. That's not what I want. Okay. Here's the same kind of question, kind of written down in more words. Let's find another one that does convergent, divergent. There's not too many of them, unfortunately. I think there's, okay, look at that guy, 23. Oh, and they've changed the letter to k equals instead of n equals, good. This piece here, right, the k squared over k squared minus 4k guy, what is the limit of the individual pieces? What's the limit of k squared over k squared minus 4k?
Just one.
Okay, what can you say about that series then?
Diverges.
End of story. And that's left blank because if it diverges, I guess you could put infinity, but they don't even want that.
They want you to put diverges in. If
Oh.
it's-
Oh, okay.
So it doesn't have to be all capitals. I tested it last night.
Okay, so any version of diverges you like and you're good to go. Let's see. Okay, let's look at 25. What does 1 over e, 8 plus e to the negative n get you? What's the limit of the individual pieces? Do a brute force on that one.
Limit of the
Did you-
1/8.
1/8.
Yeah, I hear a 1/8 from Molly. Is that where you're going, Will?
Yeah, I
Sorry?
was just looking for the word for the one that's not adding it together. So it's
Okay.
I know my vocabulary here.
Okay, so what we've got here is 1 over 8 plus e to the negative infinity. Think of that as 1 over infinity, so you get 0. So it's 8, and because it's 8, wouldn't that make that a divergent? Right. Would you agree that is going to be an 8th? And so it's going to be the log of an 8th. Isn't the log of an 8th a number, so it diverges? Have you noticed that the only thing a divergence test tells you is the ones that diverge? Right, so you're probably not going to get, although I wish they threw one in, where the answer is inconclusive, right, where you can't tell. But they're not doing it, so that's fine. Oh, there's a good one. If you use the divergence test on e to the power of n divided by n to the power of 7, what's the limit of the individual pieces this time? At the end of yesterday, I gave you a funny little list of hierarchy, and we talked about the thing on the top kind of fighting the thing on the bottom.
Isn't e to the n larger than n to the 7th?
Yep, so the conclusion is that that limit's going to be infinite, isn't it? I don't think it's a surprise then if you add up a whole load of things where the things themselves are getting infinite, the answer is going to be really, really infinite. So it diverges. But if it adds up to a number, it's going to diverge. If the individual pieces all add up to infinities eventually, don't you end up with an even more infinite answer, right? It's really, really diverges, if you wanted to stick an extra really on it. And that is how the divergence test works. There is a little problem with the questions I just did. Not one of them said, use the divergence test. I just knew by looking at them that those particular questions would be suited to this test. So that means you have to be aware of what test is appropriate for which series, right? And the ones that we did look quite different in lots of ways, right? So that's going to be a challenge for you to try and look at something and find out what the correct test is. But that is the divergence test. Now, I'm going to skip 4 for a minute, and I'm going to look at what's called the geometric series test. And the reason I'm picking that one is, didn't we touch that yesterday? Didn't we talk about that one yesterday? So let's remind you how that works. You know, a geometric series is one that you start with the number and then you constantly multiply by things, right? So in general, every geometric series in the universe can be written down in this format. And if I plug 1 in, you get that. Then the next term, you get that. And then when you plug in 3, you get that. And you plug in 4, you get that for infinity. That's what every geometric series looks like. Essentially, you start with one number and you continually multiply it by the same amount as R value. And then you add the whole lot up. And they're called geometric series test, or a geometric series. These individual terms are a geometric sequence. Right, if I put commas between them, they're called a geometric sequence. And all you need for a geometric series test is, if the absolute value of R is less than 1, the series converges. And if the absolute value is greater than 1, the series diverges. What do you think you get when R is equal to 1? So you start with a number and you multiply it by 1 and you get the next number, and you multiply it by 1 and you get the next number, and then you add them all up. What do you think that series does? Converges or diverges?
Wouldn't it diverge?
Correct. So that guy gets the equals. Think about it. Suppose I started with 3 and I multiplied it by 1. Wouldn't that be a really boring sequence? But technically, isn't it still a geometric sequence, right? You start with a number and you multiply everybody by 1. What would happen if you added these up? Can you see it would become infinite? And can you trust me that if you do -1, the only difference you get is 3 plus 3, take away 3, add 3, take away 3, add 3. And the answer bounces between 0 and 3 for eternity, which also counts as a diverge. So for geometric series, you just find that guy, what's called the common ratio. And if that number is, less than 1, so -1/2 will converge, +1/2 will converge, right? And that's it. And this one, you get an extra benefit. When it converges, the series, we even know what the series adds up to. A over 1 take away R. Remember yesterday I proved that to you, right? So that's one of the few situations where you can actually tell us, well, what the sum's going to be. And now we're going to have to look at geometric series questions from the homework. And I'm going to start, well, way up here. Darn it, my mouse. And skip by that. Okay, here we go. Coming up. No. Determine whether this geometric series is convergent or divergent. Isn't it nice that they tell you it's a geometric series? Because if they tell you it's a geometric series, use the geometric series test on it. Now, what makes this a bit tricky? I do not know what R is yet. Can you see that's the first term? And then this is the second term. And then this is the third term. And then this is the fourth term. Give me a simple way of finding out the R, what's called the common ratio. Don't make your life hard.
A2 over A1.
Okay, so -8/7. Agreed? A2, -8, divided by A1. Just do that. And you know, okay, maybe you'll have to tidy it up because both numbers are ugly fractions, but isn't that what calculators are for? So it's not that big a deal. Isn't -8/7, isn't that bigger than 1 when you take its absolute value? So that answer is divergent. Okay, would you agree this one is 9/10? And when it converges, you have to find its sum. So in this box, you don't say converges. What you do is you write down what the sum would be. Well, in this question here, the common ratio is 9/10. So I'm writing that down. A very simple question. What is A? What number is A?
10.
Would you agree that's dead easy to find? Isn't A the first number? In this case, 10. Now you put that package together, you know it converges. So we'll talk about the converging part first. In your test, you would start by writing that down. Then you would write down that this is less than 1, so it converges. And the reason you're writing that down is to prove to me that you didn't guess, that you knew it was because it was less than 1. And then there's a formula, isn't there, for finding out what the sum is. And it's that formula. And so it's A over 1 take away R. So it's 10 over 1 take away 9/10. And can you trust me, the answer is 100. And that's what you would write down in the box. You just write 100. So that's all WebAssign homework wants. It just wants the number 100 in this case. If it diverges, it just wants the word diverges. Is the geometric series test a pretty simple test to apply? Just find the R value and you pretty much know everything you want. So let me return back to the homework and look at some more versions of that question. Question 15. What is the R value for that geometric series?
(8/10).
Okay, which is -4/5. Would you agree that's less, its absolute value is less than 1? So it converges. And won't the A value be 10? And then off you go and do the rest. Okay, this one's been sneaky. They've already written it down as the series, right? Rather than the sequence they come from, right? They've got a series. Look at that one. What is the R value this time?
4th.
Okay, so it converges. Great. And then can't you use the A over 1 minus R to find out what it converges to? Nice, easy test. Now, this one is also a geometric series, but it's written down using sigma notation. So it is a little bit harder to find the two numbers that you want. You only want really know two numbers. The first one you always want to get is the R value, right? Because that tells you if it's going to converge or not. When the formulas are written as AR to the n minus 1, that's essentially the way this is written. Can you see that the R value is always going to be this number here? Can you trust me on that? Does it seem reasonable that that's the R value? So in this case, isn't it convergent? So far, so good? Now, since it converges, don't I need to know what A is so I can do the A over 1 minus R thing? Now, getting the A value is easy here because the A is 2. And it's easy here because A is 10. How on earth am I going to get the first number out of that thing?
Could
Put it in
you
your
plug,
calculator.
Okay, and what value of n will I use to calculate it?
1.
1. Can you trust me the answer's 20? Now, in a lot of cases, it probably will be that number there, but you got to be careful. They can change that and make it n. They can also change that and make it n plus 2, because that can happen sometimes, right? It's still a geometric series. It just means that when you plug in n equals 1, whatever you get is the a value. In this case, it's 20, but I'm just saying, be careful, because it might be 20 times 0.55 the next time, or 20 times 0.55 squared the next time, because it's not n minus 1, it's n plus 1, right? That still counts as a geometric series, right? There's a cool one. What is the R value this time?
Is it 1 over pi?
I like your thinking, yes. Now you've got a harder job. Explain to the other people why. You're right.
Well, you could take the denominator just out. If you make it into a multiplication, more like the summation that we have in the notes, then you could see it like that.
Okay. Let's see if I can visualize what I believe you're saying to me. At least this is the way I'm hearing it.
I think the best way to look at it is 9 times 1 over pi to the n.
Which is kind of what I heard Molly saying, but people say things, and yeah, what am I trying to get at? We express the same idea in different ways. So it may sound like you're saying different things, but really you're saying the same thing. So what you're saying is correct, what Molly was saying. Then you can think of this like that. Do you see the R is more obvious? Is that kind of the second part of both Molly and Tim's way of saying that? And I'm seeing some nods, so we're all agreeing on that. So in this situation here, right, wouldn't R be 1 over pi? And can you trust me, that's less than 1, so it converges. Now, back to the original question here. What is the A value? And be careful, it's not 9.
9 over pi.
Yeah. Remember, to get A, you plug in 1. And if you plug in 1 here, you get 9 over pi to the 1. So it will be A over 1 minus R. It will be 9 over pi over 1 minus 1 over pi. God, that is ugly. So we need to do style points on that answer. I do not want to leave a fraction with a fraction in it. Anybody got a clever technique for making this fraction look prettier? Multiply by a special version of 1. There's my clue.
Would you multiply both the denominator and the numerator by 1 minus 1 over pi? Kind of like the conjugate method.
Oh, like the conjugate, where that would be a plus if you did that. That's an interesting trick. No, I don't. I'm not saying that's a bad idea, but I know it's not going to help too much. You still don't get rid of the fractions. Any other? But it's a nice thought. I would definitely
Multiply
do
by
that.
pi over pi?
Yeah. So yeah, if I had square roots involved, Rosie, I would probably do what you just said. But in this case, what you get, would you agree that looks much prettier? And that would be the answer I would expect to see. So if you get something that is a geometric series, all you need to do is find its R value, and that will tell you whether it converges or not. And then after that, if it does converge, you then have to go hunting for what the A looks like. So I'm now going to go back, if I can hit the right buttons. There we go. And look at some more geometric series. Question 19. What is the R value? That's not so obvious. What's your gut feeling? Because guess what? It's probably going to be right. What do you?
Is it -8/9?
You nailed it. It will be. So you might say, well, I can't just rely on my gut because sometimes my gut tells me the wrong answer. If you really wanted to know what it's like, couldn't you put n equals 1 and get the first number? N equals 2, get the second number if you needed to. N equals 3 and get the third number, right? Just write down the individual terms. And then couldn't you do A2 divided by A1 and get the R value? And it would end up being exactly what you said, Rose. It would be -8/9. Wouldn't you just plug n equals 1 into that expression to find out who A was? And that would get you the first number. And you come to, I'm only verbalizing that, but do you understand what I'm saying? Find A1, find A2. If you divide those two, that's the R value. And if you keep A1, you're good to go.